So in this recording, I am going to show you the graph memory capability of mem0. So today we'll just see the capability, and during the weekend I will demonstrate more the inner workings of the graph memory, how the prompts are written, how it is actually extracting the nodes and relationships. But this is the documentation of graph memory, and this is very close to my heart because I have been talking about it for a long time. Um, I have written some articles on it on associative memory, similar to how human memory also works, right? So I was very excited and glad to see this graph memory in mem0. Uh, so basically, to use the graph memory, the main thing is that you need to give a configuration, Neo4j configuration. And when you instantiate the memory from this configuration, and then when you add memory, it adds the, uh, it extracts the user preferences or the user ask from the response, and then tries to create an associative memory about the user, right? That's what we'll see. So memory.add adds it to the graph. One thing I found out is that the get all, even if I give a user ID, it is actually retrieving all the memories of all the user IDs. Not for this. I uh, highlighted this to the mem0 team. They're working on it. I am also going to look at it, why it is happening like that. Uh, but overall, this feature is I like this feature a lot, and that's how I think the memory architecture should go, right? Where memory is not just one monolithic system, it's a system of systems. It's a subsystems where I should have graph memory, I should have semantic memory, graph memory, I also call it associative memory. Then there are other types of memory like entity memory. So the associative memory can also be like a episodic memory, right? So it's a huge subject, memory. We can talk about it at length. Um, but good to see some of the products are thinking about it and then developing something, right? So let me now run some code to show how it works. So what I have done is I have a Aura database. Okay, it is disconnected. Let me connect it again. Hopefully, yeah, password is still there. Okay. So I connected it now. In fact, I should be able to, yeah. Okay. So this is empty right now. If I say match and return an RM, right? Right now it will be all empty. But now let's start some, let code something, let's use that graph memory. So what I have done, so in my last recording on mem0, I showed how to integrate it with uh, the mem0 with LangGraph, right? There I used a travel agent. I took this same example, right, where the only thing is now I have a graph configuration where I have provided as new4j, right? I have the new4j URL, the username and the password. I'm creating the client from this configuration, right? I'm using OpenAI, user is Sohan, right? This is the LLM. And now everything remains same as my previous example. Only change is now I am adding the memory. So this is my completion, but I'm adding the memory. Okay, where I'm adding the memory. Somewhere I'm adding the memory. Message content. Okay. So this is where I am adding the memory. Now I'll go in depth in my next recording to show how it is being done. But quickly, I want to show one thing. If I go to add memory, now you will see there is a uh, graph, right? Self dot. So there is a self dot enable graph equal to false, right? But if I in my config, if I have the version as 1.1, right, or and I have a configuration, graph store configuration, that then I create the memory graph, right? And how the add is happening is there are a lot of things happening here, which I'll explain later on. But wanted to show one other thing where like where I saw that mem0 is actually using the structured output uh, capability of uh, uh, OpenAI. So let me see. Okay, so I think it is in the memory graph, right? If I go to the memory graph, oops, let me come back again to here. Okay, if it is V1.1, right? Where it is adding, right? This is the part I think. Okay. So if metadata add, if not prompt, okay, let me come back to it again from here. Add. So graph memory, store search, where is the graph memory? New memory. Okay, this is the memory graph, right? If I go here in the memory graph add, this is where, if you see, this is where the structured output function of OpenAI is being used, right? But I'll go in depth because I have um, analyzed this code and then I have notes, right? But in this recording, let's just look at the capability, right? So basically now I have the configuration, graph configuration. I have the system prompt, right? And then this is where I'm creating the response by the LLM based on a question. And this not the response, I'm adding the query to the graph, right? From the query, uh, it will try to create the memory graph, right? So let me run it. Oops. Yep. Okay. So it will start now. It's a travel agent, right? So I mentioned that you are a helpful travel agent. You provide vacation travel consulting service to your customers, right? So I'll say, I want to travel to, let's say, Summit. Can you suggest some good places to visit, right? So now it is, okay. So it gave me the answer and let me go to the memory. Okay, so it has created the memory. So user Sohan wants to travel to Yosemite, right? Let's build more memory, right? Okay. Um, okay. So what are other places nearby that I can see, right? Let's see what it does now. So if I, okay. Okay, so no memory has been captured for this because actually there was no nothing to be captured. I'll say, okay, I would like some good food. What are my options here? Right. So, so it's remember since I'm getting the memory, since you are interested in visiting Yosemite, right? So now it should actually also create a food, right? Good food, right? Wants good food, right? So this it created it. And one thing is for each of the nodes, it is creating embeddings also, right? For each of the nodes, it is creating embedding, right? And it captured this, right? I also like tracking. Would really love to find out some tracking options there, right? So now, so it should capture this also. So gradually in like a the memory, like it's the user preferences are being captured like a graph now, right? So it uh, captured the tracking part, right? Good food, isomite, right? Let me exit out of it, right? And now let me try again. Let's see what it does. So it's hi. Okay. So it is remembering now. Are you planning a trip to Yosemite soon? Or is there something specific you're looking to do? I dropped the plan to travel to Yosemite. I now want to go to Hawaii. Let's see what it does now. Are you looking to a specific island or yeah, it is asking some question, but let's see how it changed the, yep. So now it says, yeah, let me, Sohan dropped plan to travel, wants to travel to Hawaii. So see, it updated the relationship, right? That's what I wanted to show because when I was going through the code, there are prompts which is actually also telling it to, like if there is a change in relationship and all, it changed that also. So here it changed that relationship, right? One thing though, that so how I think about human memory is it's like a uh, uh, write once log, right? It's always appending. So here, although like it created the new relationships, the old relation, right, where Sohan actually had a intention to visit to Yosemite, that is lost. This is where some of the concepts that I have does not match, right? So my idea of a memory is like Kafka, like an event hub, right? It's like a log, it's an append log. Right? I don't go and update the previous memory. I keep on adding to the memory so that I can time travel and I can know that at one time I had an intention to visit Yosemite, but now I don't have. But now with this update, that history is lost, right? I no longer remember that once I had intended to go to Yosemite. So this is one thing that is not matching to how I think about memory, right? But anyway, I just wanted to show this capability. This is a beautiful feature. I will be playing with this features a lot and then come up with more ideas and then more findings from my side. Thank you.